Hello, everyone. Hello. Hi, everyone. Morning all, morning Wati, poo. Ooh, that's Dan actually, but okay. All right. So, good morning, everyone. Welcome to GDG Cloud Devfest 2020. This year we are a little bit different. Everything's online and yeah, everything's virtual. But again, GDG's Cloud is still alive and safe, everyone. So let's move on. So GDG Cloud DevFest is part of it's part of one out of many DevFests in this month. So as you can see before our machine learning session, there's web, Google Developer Space, Android, and Google Cloud as well. So what happens after today? After 12 p.m. today, there will be a Firebase session conducted by GDG Cloud Kuala Lumpur. And yeah, after today as well, on October 24th, there's a rework session and women tech makers. So do check that out. It will be coming on their Facebook page and their YouTube channels as well. So yeah, moving on is that besides having our quarterly, monthly meetups and also online meetups right now, there is going to be a GCP Bole 2.0 version coming, and people are already starting signing up. Recently, there are some issues in getting credits, but we are currently sorting about it, and we'll come back to you all by the end of next week at least. So if you're interested to learn more about Google Cloud Platform, the tools and technologies, and to level up, and in the same time, most importantly, to score swags, do check out through with the link below here. So google.google and /GCP Bole. So that's where you can actually check out for more information. Now, what we are having today is that there's going to be 3 awesome speakers, but there is some slight changes in plan. Asyrul, who is the second speaker, will be going first today, and Armel will be actually moving back to the second session. So what you'll be looking forward to is Asyrul presenting on the practical problem solving with artificial intelligence and machine learning, and follow up by our second speaker, Armel, and third, Aqsa from Pakistan, who is a GD in machine learning. And that is it for the simple introduction. So if you are interested to follow us, actually not interested, don't be interested, you should follow us. Make sure that you type in, we are very active on Facebook, so you type in GDG Cloud Kuala Lumpur, you can see the big cloud logo here. You can also see a big cloud logo on my shirt here. And just like our page, follow our page, then there's always cloud updates or events update there. Now, without further said, enjoy the session, and I'll pass the virtual mic to Asyrul. Hey, Asyrul.
Hey, hi. How are you?
All right, give it away, man. I'm gonna remove myself.
Okay,
Okay.
so hello everyone. Good morning. I hope everyone is having a fantastic Saturday morning. So my name is Asyrul Ahmad, and recently I just graduated from university studying artificial intelligence. And for my master's project, I built a chatbot which could conduct small talk conversations with the user. But the main purpose of the chatbot is to help user carry out data wrangling or data preparation. For the chatbot, I use a deep learning algorithm called LSTM to classify user questions into predefined sets of question classes, and I implemented using the TensorFlow library. It's essentially a deep learning library created by Google. Currently, I'm working as a full stack software engineer at Strands. It's a fintech company based in Barcelona, and they specialize in AI-driven solutions to help banks all over the world to manage finances. And today I'll be talking about practical problem solving with AI and machine learning. And we aim to achieve these three main objectives. The first one is we want to understand the big picture, what is AI, and how it relates to ML. And we often see the word, AI often seen together with ML. Are they the same thing? Are they not? How they relate to each other? The second one is we want to actually understand the nature of machine learning problems. So it's important to know that machine learning does not solve all problems in the world. So we want to know what sort of problems machine learning can solve so you can implement it in your businesses. Third, we want to understand the requirements. If you decide to implement machine learning, what do you need? And based on these requirements, we can see some of the trade-offs and challenges as well. Okay, let's start with the big picture. All right, so these are the words related to AI, and depending on where you are, for me, these words appear like almost every day, everywhere now. So for example, like machine learning, deep learning, big data, AI, robotics. It's essentially like, business, company A is using AI to achieve something, is almost everywhere today. But have we ever wondered, like, what do these words mean? So we want to get a clear understanding what they really are, actually. So let's start with the word AI itself, artificial intelligence. What is artificial intelligence? So of course there are many definitions out there, but what it essentially is a study field which aims to replicate human capabilities on machines. So what are these capabilities, human capabilities that we want to replicate? So we could think of ourselves like we can see, we can move, run, climb, we could learn new things and be good at it. We can read, we can talk to someone, we can argue with them, we can reason with them, we can listen, and so on. So of course, human capabilities, they're endless. There's so many of them. But in AI, for each of these capabilities, there exists a field in AI which aims to replicate that capability into machines or robots. So as we can see here, C reasons. So for each of these capabilities, there are an AI field which aims to replicate that capability. So for example, seeing, there's a field called computer vision, and reading, there's NLP, reasoning, automated reasoning, and so on. So for each of these study fields, they have their own techniques as well. Therefore, it's really important to understand that machine learning is not the only technique to solve AI problems. There are many other techniques that have been implemented all these years by each and every one of these fields, which have been effective in the past. So remember, machine learning is only one part of AI to solve AI problems. Okay, but today, of course, we'll be talking about machine learning. We're not going to go into computer vision or anything like that. So what is machine learning? Okay, so in Andrew Burkhoff's book, the book is called 100-Page Machine Learning Book. It is a really good book because it's only 100 pages, not very thick, and it's really good for introductory, but it's also useful for people like me. But anyway, from the book, it defined machine learning as building algorithms which rely on a collection of examples of a given phenomenon. So algorithms here are sometimes referred to as models, machine learning models, machine learning algorithms. They're basically the same thing. which rely on a collection of examples. So we will see in a bit what examples are, but the word examples here are often interchangeably used with samples, inputs, and so on of a given phenomenon. So this is related to a particular problem or particular domain. Okay, so have you ever wondered what does a trained machine learning model look like? So let's say, you train a model, machine learning model. So have you ever wondered how they look like? Do you think they look, like any of these? Maybe like Terminator or a fancy robot thing. But actually, models, they look more like this. Yeah. So, I mean, I'm not really going going into detail in each of these, what is E, what is B, and all that. But my point here is models are usually in the form of either algebraic equations, trees, graphs, probability distributions, and that's not really something you might expect. Okay, now let's move on to understanding machine learning problems. So we'll look into the nature of the type problems that machine learning can solve. But before that, let's look at some of the popular tech giants which leverage on the power of ML today. Yeah. Okay, I'm pretty sure most of you are very familiar with all of these applications: Netflix, Amazon, YouTube, Google Maps, and they have something, something about their products or their service. It makes you feel like, for example, in Netflix you have content recommendation. For example, it recommends videos based on, shows, recommend shows based on the shows that you have watched in the past. Amazon recommends products based on the things that you probably have seen or purchased in the past. YouTube, of course, every day there's YouTube recommendations. And Google Maps. Google Maps predicts your journey time. Let's say you plan to go to destination A or B. They will give you the predicted journey time, and they all are quite accurate, right? So it makes you wonder, how do they know? Yeah, and let's think about, what do these applications have in common? They predict, right? So prediction is one of the popular and typical use cases of machine learning. And prediction is normally done by classification, although it can be done in many other ways as well. But to explain this briefly, let's have a look at an example problem. So the example problem here is, let's say you want to predict if a given person has diabetes. Yeah, so why would you want to do something like this? Why would you want to predict someone has diabetes? Well, you want to do this to identify a list of potential patients. Then if you can identify potential patients, then you can take like preventive measures or something like that, so which could prevent them from being diagnosed with diabetes. So let's say you have a historical health data which you can use to train a classifier model. So from here you can see that of course the rows are the samples, and these are the examples that we talked about earlier. And what they essentially are they're just different individuals. So each row is different individuals, and each column are their features. Now these features, it helps us to make better predictions. They are information, and usually the more information you have about something, the more accurate your prediction will be. And finally, you have the label or the class. So in this case, it's either a 0 or a 1, which means that either the person has diabetes or doesn't have diabetes. And keep in mind, this is a historical data, meaning that we already know each person either has or do not have diabetes. So it's a 0 and 1. So in this case, in this example, it is called a supervised binary classification problem. So why is this supervised? Because the training data has labels, as you can see on the right. So each sample has labels, so we call that supervised learning. If you don't have labels, but you still want to classify them or maybe visualize them, then it's called unsupervised learning. If some of your data has labels, but the others don't, then we call that semi-supervised learning. And those are quite advanced topics, but for now, we just focus on supervised, which means that each example has labels. So predictions are made on the labels. You want to predict if the person has diabetes or not. So we predict the label. So but what prediction really is, yeah, like I said, you predict the labels, but the prediction data is something that the model hasn't seen. So previously, that's a training data, which means that you use those data to train a model. And with that model, you classify or you predict a new data, the data that doesn't exist. It didn't exist in the training data. All right, and well, you might argue, like, why not we just use if statements rather than training a model and have it predict new inputs? And this may be a valid argument because sometimes you don't need machine learning at all. So that's why it's essential and important to understand the nature of your problem. Do you really need to use ML to solve your problem? You could, in this case, you could define like a if statement, like a very complex structure of like, if age is more than this, blood pressure is more than and whatnot, and you can give out some output. But in this case, probably you can do. I mean, you could do that because you have like 3 features here. But in reality, you cannot predict something based on so little information. Like I've mentioned before, the more information you have about something, the more accurate your prediction will be. Therefore, in reality, you probably have like 30,000 features to help you make predictions. So how are you going to if statement that? That's not going to work. Besides, sometimes there are outliers. So what does outliers mean? It means that people who are diagnosed with diabetes, but they don't follow the rules that you specify. Like they don't follow a certain rule, they suddenly just get diabetes, and that's probably because of genetics or something. But it happens, right? So if statements cannot capture these because they are outside of those rules, but machine learning can. Okay, so back to our example earlier. How do these applications make accurate recommendations every time? Well, of course, by leveraging on users' historical data to train their models. So, when you use the applications, your data is being collected, and using those, data, they train their model, and they can come up with a really robust machine learning model. So, to recap, suitable problems include classification. So, for example, you want to classify scam emails, which currently is being implemented in Gmail. If you want to classify categorized images based on something like, for example, your iPhone, you facial recognition, you categorize. So that's also part of classification as well. The other one is prediction. If you, prediction is quite related to classification, but in terms of example, you probably want to like forecast weather forecast, for example, predict journey time, like in Google Maps. Recommendation as well, like the ones being used in Netflix or in Amazon. I mean, if you plan to build your own e-commerce systems and you want to have the recommendation feature, that will be helpful. And finally, visualizations. So visualization is related mostly with unsupervised learning, because we cannot visualize complex data. And what do you mean by complex? Complex means high dimensional. They have, 10,000 features, and you cannot visualize that because our visualization capabilities or our imagination is only limited to 3 dimensions. You cannot visualize high dimensional data. So the only way to do that is using unsupervised learning techniques, which can help bring those dimensions down until you can visualize them. Okay, so let's say you decide to use machine learning, and what does it need? Well, first it needs data. So effective model training, it needs a lot of data, especially deep learning. You cannot get away with 100 samples. That's too little. So you need more. You need like thousands, millions. The more data you have, the more accurate the more robust your model will be. But what's the challenge of collecting data? What's the big deal? Well, the challenge is, where do you get these data? How to obtain data? So you might have a business and you have like your users or your customers, clients' data, and you decide to use them. If you decide to use them, are they aware of it? Are you aware that your data is being collected for the advancement of AI? Are you aware? So you're probably not aware because you don't know, because it happens behind the scenes, right? So in fact, data awareness is not data awareness. Data ownership has been an increasing awareness in the last several years. That's why it's a challenge. You cannot simply take data from here or there. It becomes if someone catches you, you're in trouble. Also, finally, your data must be convertible into numerical forms. Most machine learning algorithms, I'm not saying all, some of them you can get away with, string values, but most machine learning algorithm, it requires your data to be converted to numerical values. Because like I said, models don't look like Terminators. They look more like, mathematical equations. So you cannot pass a string value in a mathematical equation. You must pass like numbers. So your data must be converted into numerical forms. Think about RGB values when if you want to do image classification. If you want to do NLP, you have to look up word embeddings. Those help to transform your sentences into vector values. Also, if you want to deal with categorical values, you would have to implement like one-hot encoding to convert them into numerical forms. Okay, the next one is computational power. Machine learning is very computationally expensive. You need very powerful machines. Wait, what's wrong? You need very powerful machines to carry out optimal model training. Unfortunately, today there are cloud services which provides those computational power, which includes Google Cloud Platform. And you can see in later presentations by the other speakers to learn more about this. Yeah. Also, you need expertise. Machine learning engineers, machine learning or data scientists, they need to be trained to take scientific approach when it comes to solving problems. they also need to be equipped with essential machine learning skills. For example, I mentioned earlier one hot in coding, and maybe they need to know cross-validation, how to compare performances between different models. There's so many theoretical methodologies they need to know for them to be able to come up with a robust model. And they also need to be well-versed with data preparation. As I mentioned, for my master's projects, I built a chatbot to help users conduct data wrangling or data preparation. And the reason why is that I will show it in the next slide and time. So this is related to the expertise as well. So let's have a look at the data science workflow. So this is what I mean by it takes expertise and time. So as you can see here, start and machine learning, there are a few steps which you could finally reach that machine learning step. The first is, of course, data acquisition. You need to obtain the data either from a database or you collect it from sensors or something like that. But you need to obtain the data first. Then you need to profile them. And what does profile means is you need to understand your data. You have to see missing values, or if there are invalid values, if there are outliers. And you probably need to attempt to fix them in a phase called transformation, data transformation. So in this stage, you fix those data anomalies, as well as you need to remove unwanted information. Let's say you have 1 million columns, right? So you probably don't need all of those because some of those are irrelevant information. You probably want to reduce it down to maybe 500,000 columns or something like that. So these are called transformation. And after transformation, you need to integrate. You need to enrich your data, add more information to it, relevant information, of course. And these three steps, profile, transform, and integrate, is an iterative process. And this iterative process is what is called data wrangling or data preparation. And data preparation has been quoted in many research papers that it takes 50 to 70% of the analyst's time. So the real challenge here is data wrangling, data preparation. Is prepare your data to be perfect so that you can finally use it for machine learning. And once it's ready, then you can feed your data to the whatever algorithm or model you want to use and train it. Okay, we covered the main objectives. Now, moving forward, if you want to get into machine learning, well, if you have a business and you want to implement machine learning, of course, the fastest way is to hire a data scientist or a ML engineer, something like that. But if you want to get your hands dirty, I would say first you can learn Python. Python is currently the most powerful programming language today. So if you're living in this age, you don't know Python, you're missing out. There's so many things you can do with Python. And yeah, the first step, I would say, I mean, you can implement in any other languages as well, but Python is quite friendly because it's high level, easier to learn. Then you can expose yourself to basic machine learning through scikit-learn. Scikit-learn is a great website to learn machine learning algorithms. And then you can start exposing yourself with deep learning. And there are many libraries out there. The ones I use, TensorFlow, PyTorch. TensorFlow is built by Google. And finally, you can challenge yourself by taking data science challenges and improve from there. And one website you can do that is Kaggle. Kaggle is where, sometimes they put up a public challenge that you can solve and try to compete. So if you get a good ranking, you can impress your future employers maybe. And you also need to know maths, linear algebra, lots of linear algebra, most machine learning concepts. I would say 95%, 98%, they're all linear algebra. Second, linear algebra as well. Lots of them. Statistics, of course, calculus. And if you don't want to get into trouble, stealing data, you can get it from here. UCI ML repository. I left it as a link over there. It's a public data. You can use them. We used it in our university studies. Yeah, and if you're ever interested to learn programming, I do provide private classes. Check out the website here. If you're interested, email us quickly because we enroll only limited amount of students. Okay, and that's it for me. You can reach out to me at LinkedIn. That's my LinkedIn link, and also you can just email me anytime if you have interest in projects or whatnot. You have questions, feel free to reach out to me. And that's all for me, I guess. Thank you.
Right. Thanks, Asyrul. That's amazing stuff. That's amazing stuff. So because I'm not really a technical person, but I do understand quite most of it because of the high levelness.
Oh.
Yeah.
Okay.
Yeah. So I think that is great. So we do have some questions here, but before I jump into the questions, I would also like everyone who is watching from YouTube, specifically YouTube, that do not worry. This session, although it's live, it is recorded and will be always on our YouTube channel, so you can watch it anywhere, anytime. So yeah, that's that. There's no worry. All right. So we move on to the questions here for Asyrul. Is that let me see. Oh, that's a long one. So I'll paste it here for Asyrul to see as well. So it's about the epidemiological data in medicine be useful in machine learning? Will this data be used to create algorithms that would be helpful for doctors in diagnosing diseases?
Of course, in today's age, data. Okay, I learned this during my classes. So basically, any data you have, it is as important as your organ. So whatever data you have, you can leverage them and use it for advancement in your whatever system you have, or probably in healthcare to solve specific problems. And it depends on the information that the data you have, which can lead to solving specific problems. So in this case, epidemiological data, it is really I would say it very when it comes to epidemics or pandemics that we don't know what to do. Like what Bill Gates said in his talk, many years ago, that we don't know what to do when something happens, like epidemic or a pandemic or something like that. So whatever data you have, it will be useful. You just need to know what information it has and what problem it can solve. Yes.
All right. I hope that answered your question, Akim, Aris. So we'll be moving on to another set of questions from Afiq. So this one, it's related to chatbot. So the first one is actually which chatbot framework you use, Asyrul, by using LSTM, and the second is why LSTM rather than a transformer.
Okay, so my project was not to compare algorithms. It's more of a building thing. So in my justification, I chose LSTM because it works. It is proven by research that it works. So because I had to build a full-fledged chatbot in like months. LS, my objective, which was the chatbot, is just to do some reading and choose the one which works, which helps me achieve my objective. So in this case, I'm not very familiar what transformer is, but LSTM, it has been proven like many times that it works. So that's my answer basically.
All right. Okay. Cool. So I think Afiq, if you are trying to clarify your question like transformer, something like that, do actually contact Asyrul via his LinkedIn or Facebook. Other than that, so you can actually ask for more information. So I think the third question is this:
I would love.
Can you recommend some Python libraries that are specific for ML use?
Okay, for me, the most basic library that you need to have is scikit-learn. Scikit-learn provides machine learning algorithms. It also provides some of the methodologies that you need. For example, train, test, split. So when you get data, you need to split your data into train and test. Scikit-learn has that, so it is helpful. Scikit-learn also provides evaluation features. For example, F measure. So scikit-learn is number one. For data preparation, I really recommend Pandas. Pandas is like really powerful. You can basically transform your data, quite effectively with Pandas. Of course, NumPy, you need it for the vectorization and transforming into arrays and all that. For deep learning, like I said, you can use TensorFlow or you can use PyTorch. PyTorch is quite new, but I've read that they are good. So you can experiment with PyTorch and TensorFlow both. TensorFlow developed by Google. It's great. It would be great if you could experiment with both.
Okay, cool. I think we have one more question from Daniel Owen. Is that that's a long one. So this is guys, this is the last one. I'll show the contact link to Asyrul so you guys can ask as many questions to him as well. So the last one is from Daniel. Is that do you see ML making redundant jobs that are reliant on diagnostic skills? If yes, is in your estimation how many years from now? Because Daniel, I'm a doctor and freaking out a bit from your presentation. From Daniel's point of view.
Okay. If you're talking about machine learning, like really diagnosing the disease for you, that's gonna take so many years from now. You probably, it's probably not during our lifetime right now, but because machine learning is not really intelligent robots. If you think about it, they're just mathematical models. So you cannot rely on those. They need to be really accurate for you to be able to completely replace real doctors. But machine learning can help, like in my example, it can help you list down the potential patients. So that could be really helpful when it comes to treating everyone, or you can just treat or give warning to just a limit, a subset amount of people that you think has the potential to be diagnosed with a certain disease. So machine learning can be really helpful, but in my opinion, it won't replace real doctors. Probably not in the next few like 10 or 20 years, because they're not really intelligent. They're just they're just mathematical models after all. Yeah. Hope
Alright.
that answers the question.
Yep. So I think to conclude for Daniel is that don't worry, you can still be a doctor. Yeah. So it takes a while for machine
Don't
learning to
worry.
catch up. Yeah, don't worry. You can still be a doctor. I think I'll choose one more question, which is
Yeah, sure.
slightly different from the technical one. It's from our friends from GDG George Town. It's about business right now. Now, how do we use ML for small businesses, like for start, like say from the e-commerce line? How does it work? Yeah.
Can you hear me?
Yep.
Okay, so for small businesses, like like I showed in previous slides, first you need to figure out how you want to, then by all means proceed. Of course, the first step is to get the data, and once you get the data, you can think about how you can leverage those data to build for example, a recommendation system. So even to build this, it's not as simple as adding. It's not as simple as adding a small module or something like that. You need an architecture, like for example, where you want to store your data and where you want to host your ML model. So you probably need to make an API request to the model that you have built, and you have deployed, passing whatever user recommendation or something. Think about the architecture of your solution, how you want to use the data to train the model, and how you want to use the model from your app. Yeah, so that's probably how you want to. But for small businesses, if you want to invest, I mean, if you are already an expert, or if you're already fluent with data science workflow, or if you're already an ML engineer, you know what to do, then that would save cost. So you have the data, you already know what to do. Expertise, you need to hire a ML engineer or a data science, and that would be costly for small businesses, in my opinion. So of course, like I said, first collect your data. Second, you need to architecture your solution. But most importantly, you need to evaluate if you really need these features in the first place, especially if you're just like, depending on your scale. Yes.
Cool. All right. I think that is the end of all the questions. So again, I'll actually post Nasrul's contact LinkedIn here and his email. So if you guys have any more questions, unfortunately we have to take our break, a 10 minutes break after this. And if you guys have any more questions for Asyrul, feel free to message him on LinkedIn via this LinkedIn here, or email him if you're email person. So I'll leave it here for maybe like another few seconds, just so you can take a note down, or easier solution is just screenshot this entire thing. Yeah, just take a screenshot of this entire thing. All right.
Yeah, that would be interesting to have more conversations about this.
Yeah, true. I think okay. Yeah, so we'll be taking 10 to 15 minutes break, everyone. So grab a coffee, grab a tea, a cookie, and prepare for our next session. We'll have Aqsa's coming in. So that's great. That's great. So once again, thank you, Asyrul. It's a fun talk. It's a really, really interesting and light talk.
Yeah,
I
sure.
get a lot. I get a lot. I'll share around with high school students as well. I believe they will also get it. All right. All right. Yeah. Thank you. Thank you. See you guys in 10 minutes.
Honest with you, I
Yeah.
think the connection is a bit.
Yeah, I think it's Shopee.
Sorry?
Yeah, you were saying?
Yeah, I was saying that when I was studying my masters, I realized that those things that we learned in high school, they make sense now. For example, in high school, you learn about vectors, you learn about those Cartesian planes and coordinates and all that. But at the time, we didn't know why we were learning this. Like, what application? How is this knowledge going to be applied? But once I studied my foundations of machine learning, then I realized, oh, that's why we learned this. It is to to implement something like this. Yeah. So, like you said, it would be really helpful for high school students as well.
Yep. So those of you who are still studying in high school and watching this video, do do focus on your maths if you're trying to be an ML engineer. Yeah. All right.
Yeah,
All right. So I'll move your call out, and we'll take a 10 minutes break, and see you all in the next 10 minutes. I'll put the Devfest video as well. Let me know you guys have problem watching it for 10 minutes. Let me share my screen.
with remote work. Nearby in Romania, GDG groups organized a hackathon, gathering 270 different mentors and students from across 8 different countries. The hackathon brought together developers to save lives, to save communities, and to save businesses. Some of the winners included an online platform that connected volunteers with nonprofits across the region, a system to help doctors work with each other and to ease online consultations, and a personal assistant for health and nutrition tracking. Another cool app that they developed was Risk Alert, an app that alerts emergency rooms that a patient with a very rare disease is about to arrive so that the hospital can prepare for any special needs. In Asia, GDG Tainan initiated the mask inventory map at the start of COVID-19, which crowdsources mask inventory from local store data, combining it with the Google Maps API. The project was so popular that it caught the attention of Taiwan's government, inspiring them to publish public data APIs on mask inventory, managed by the government. Taiwan's digital minister has since encouraged the GDG Tainan chapter to create more than 100 different apps to help the local community. In India, GDG Cloud Pune used machine learning with TensorFlow and GCP to help their community with an app that remotely analyzes dental health and helps patients book at-home dental services. They've had over 300 trained images so far, and the developer community is working with local universities to gather more than 50,000 dental images to improve the application. In the Middle East, the region's largest International Women's Day event was held in April in Turkey by multiple GDG groups working together. They had over 2,500 attendees to the event, which included a raffle for online courses and talks in artificial intelligence and data mining. The event helped women across the community and across the region learn and apply their skills. And of course, here in the United States, the GDG Memphis chapter has joined GiveCamp, where software developers in the area donate their skills for nonprofits, as well as helping kids learn to code on the weekends. These are just a small sample of the ways that Google Developer Group chapters and communities like yours all over the world are learning together and giving back what they've learned to really help people's lives everywhere be better. I encourage all of you to continue, be in community with your fellow developers. Think about how can you use the skills and the tech that you're learning this weekend at Devfest, as well as the networks and the communities that you form, the new friends that you make. How do you combine all of these to make a difference in your own area? Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture. But when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako eddagala okulaba nti akako okulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obussebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Mukyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetonya. Tulina essuubi tetufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for Devfest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app. So to get started with Android, let's see what Chet can teach us.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and ML Kit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has the on-capture success function. We get the received image into the format we need for ML Kit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and ML Kit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start.
Hello, everyone. Welcome back. Your cookie, coffee, or tea. All right. Can you guys hear me? I think yes. Yep. Right. So, due to some scheduling changes, problems, we have actually moved our speakers up. So our next speaker is Aqsa from Pakistan. So she's actually a GDE for machine learning as well. So let's welcome Aqsa to the screen. Hi, Aqsa.
Hello, how are you?
Yeah, I'm good. What time is it in Pakistan?
It's 8 a.m.
Okay, not too bad. Okay,
Not too bad. Yeah, we're like 3 hours behind. Yes.
Not too bad, not too bad. So
Yeah.
Do you mind sharing your screen? All right, so that I can place it on the stream itself.
Just a second.
All right. So everyone who is watching, you can prepare your notes, you can take screenshots, prepare to ask questions after the session, and yeah, just make yourself comfortable. Just a gentle reminder to everyone who is watching as well, due to some scheduling changes, Aqsa will be our final speaker today. So if you guys really have questions, feel free to ask them along. So we have time until 12 p.m. Malaysian time. Yeah, and again, as usual, if you have more questions for Aqsa later after this talk, I think Aqsa has posted a Twitter account or LinkedIn account at the end of her slides. So you can follow her, ask her, send a message to her about machine learning stuff. So a little bit simple introduction on what Aqsa is presenting is, she's a machine learning engineer at Red Buffer, Pakistan, and I'll leave the presentation to Aqsa. All right, Aqsa, take it away.
Thank you so much. Thank you. Hello, everyone. So I'm Aqsa Kausar. I'm working as a machine learning engineer at Red Buffer. And today's talk is about explainable AI. So I give an overview of the concept of explainability and how it is used to basically understand the famous black box in machine learning, where people talk about not being able to interpret, not being able to understand how machine learning model works and why do they make the predictions that they make. So I'll start off first with my introduction. A little bit more about myself. So, like I said, I'm working as a machine learning engineer at Red Buffer. Red Buffer is basically an AI-based services company based out of Islamabad, Pakistan. And I am also a Google developer expert in machine learning. And I also write blogs and share them on Medium as on different topics related to machine learning and AI. So today, as talk would cover what is explainability, why is it important, and where does it really fit in to the machine learning workflow. And then depending on time, we'll look into a sample example for explainable AI. So with more computational resources, right, with time, we've had like more computational resources that we can use. And with that, we have been building more complex models, right, with time. And so with this progression, we have seen that, we started off with rule-based or heuristic models. We moved on to linear models and decision trees, and then ensemble models, and then deep learning, deep models, and then to something that's more recently called a meta learning, where you have models that are basically creating other models. But with this progression, with this greater non-linearity and complexity, we have also seen that the models have become more opaque, right? They have become increasingly opaque, and it has become harder to understand why the models are making the predictions that they are making, right? So with this progression, we have seen that the models have become more expressive, which means that now we have like more variety of domains that we can deal with. So we have forecasting, we have autonomous driving, we have more versatile models. When I say that there has been like increasing versatility, I mean to say, okay, we have unlocked more data modalities. So we have text, we have speech, we have tabular data, and at the same time, we also have combination of these data. So we have models that deal with both speech and text. We have models that deal with text and image. So we have audio and image together being input to models. So we have unlocked new data modalities and new combinations of data modalities. With more complexity, we have also been able to make the models more adaptable. So we have transfer learning. We have been able to use even just the concept of transfer learning to transfer knowledge from one model to another, and to be able to build systems which have less data, right? And to build systems and solve problems where the data availability wasn't too large, where you had lesser data, but you still wanted to solve a problem, and it was a solvable problem. We've also become more efficient with respect to the hardware. So we have TPUs now that researchers can use for development, for research, practitioners can use to build faster, cheaper models, right? But with all of this, since it has become a lot more opaque to understand how the models are performing, and it has become harder to understand why the models are predicting the things that they are predicting. And at the same time, it has become harder to debug these models, right? Because you're unable to relate the predictions to the working of the models, because they've become so deeper in their layers, or they've become so complex in their non-linearity models, right? And this is exactly where explainability kind of jumps in. So explainability has been expressed as the ability to explain or to present in understandable terms to a human. So in more simple words, when just a second. So in more simple words, when we say what is explainability, we kind of mean to say that it is the process of understanding how and why a machine learning model is making the predictions that it's making, right? Why is it calling a cat a cat? And why is it calling an image a dog? What exactly is it looking in those pictures, and what features exactly it is focusing on to call it a dog or to call it a cat, right? And explainability is important for both ends of the machine learning workflow. So it's not just important for people who are building the model, but it's also important for people who are using that model. So for people who are building the model, it's important because they can use this to improve their model behavior, to understand and debug the model, and to make improvements and adjustments to the model, right? But for model end users, for example, people who are just using that system, who do not have an idea of how the model is performing technically, how the model is basically working, what input features, etc. it's using, but they're just looking at, okay, what you're inputting to the system and what output you're getting out of the system. But at the same time, they may want to understand more of how the system is performing. And in that case, explainability plays a good role to give model end users an overview of how the system is performing, how the model is performing on the different variety of data sets that it is performing on. So what does explainability look like for image models? So for example, you have a classifier that's basically classifying different animals, right? And so what explainability would look like for this model is that, for example, for the first image, you can see that it would give you basically the signals, the top signals that are contributing the most to the prediction. So if you're calling the first picture a bird, which basically pixels from that image contributed most to that prediction. So it highlights those pixels for you, which give the most signal for that prediction. So in this case, you can see that the beak is highlighted, and overall the general shape of the bird is highlighted, and you can judge that, okay, your model is looking at the right things when it's saying this is a bird, or when it's saying that, okay, this is a cat or a dog. Similarly, for the second image, you can see that the most signals come for the areas around the eyes and then the general shape of the animal. So how would this be important for model builders? So for example, in this case, if the signals were not, the pixels highlighted were not around the beak or the shape. Instead, they were something in the background. Right. So in that case, you know that your model is looking at the wrong features in the images, and you can make adjustments accordingly in the model. So what does explainability look like for text models? So for example, I have sentences and I am classifying them into labels such as action. And in this case, for example, when the predicted label is action, the explainability gives you outputs of these words. For example, mission, learns, kill, and these are the words that are giving the highest signal for that prediction. So it's sort of saying, okay, these are the words, mission, learn, kill. These are the words from your entire sentence here, which are contributing the most to the model saying that, yes, the label for this sentence should be the word action, or the class should be action. So this is important, especially for NLP tasks, where it is very hard to be able to understand which words in your sentences or which words are basically contributing to the prediction. Then it's very hard to debug and understand how the text in your data is how the model is learning from the text in your data to make the predictions, right? Which words it's focusing most on, which combination of words are contributing the most to the predictions. When it's failing to predict something right, why is it failing? In what cases it's failing? In those scenarios, which words did it wrongly focus on? So all of these things, explainability makes it easy for you. And it can also be used, explainability can also be used to understand bias in your models. So an example of that is, for example, to understand identities in your models. I'll give a small example of that. For example, I'm trying to classify my sentences into positive and negative sentences. And I have two sample sentences. One of them says, I like Liverpool. The other one says, I like FC Barcelona. Now, both of these sentences are positive sentences, right? And they have all the words are the same except for the last word, which is either Liverpool or FC Barcelona. And ideally, I'd want my model to treat both of those sentences the same, right? I'd want it to give the same weightage to both the identity words, which are FC Barcelona and Liverpool, and I'd want it to predict positivity, same positivity for both of those words, since the only difference is in the identity word and the rest of the sentence is the same. So passing them through my explainability, I can understand whether or not there's bias in my model, and whether or not if it is giving less positivity result for either of those sentences, then I know that it's biased towards either Liverpool or FC Barcelona. And this is just a smaller example of what bias in a model is. For larger models and for larger problems, the bias is way more crucial, right? So that it's not based on any race or gender or any region, right? So you can understand and judge these biasness in your models using the explainability tool in Google Cloud. So explainability for tabular models. For tabular models, where you have a lot of features, and then you have one label class, right? So you can use explainability to understand which features in your data set are basically more important and how the different features are affecting the predictions. So for example, in this case, you can see that maximum temperature. So this is a data set. This was on a data set for bike rides, and you were predicting the durations of the bike ride depending on different features. For example, climate, rain, maximum temperature, whether it's a weekday or not, the start time, the end time, and the hour of the day, etc. So for each of these different features, it gives you like an importance chart, an attribution value for each of the features. So here, for example, you can see that maximum temperature has a high attribution value, but it's also negative. So you can just do things by it, that it is an important feature in deciding the duration of the bike. At the same time, it's also a feature that affects the duration of the bike negatively. So as the maximum temperature increases, the duration of the bike ride basically tends to reduce, right? So you can make these judgments, and you can basically, explainability makes these judgments for you, and you can basically analyze these and improve your models or understand your models better, right? So why is explainability important to model end users? So for example, the example on the top left, this is a retina image, and retina images are used to diagnose diabetic retinopathy, right? And the level of diabetic retinopathy in diabetes patients, right? So it could be low level or high level or a mild risk level, right? So a model was trained to predict the level of diabetic retinopathy using retina images. So now in this case, for example, when this was for a doctor, when they look at an output from the model, they don't just want to trust the model blindly, okay, fine, the model is saying it's mild or the model is saying it's slow. They want to be able to trust that model. And for that, explainability plays a vital role. So in this case, for example, when it says that it's mild diabetic retinopathy, the explainability module would also give you why it thinks that it's mild. So it'll highlight the pixels that contribute the most to this prediction. So here, for example, these 3 regions are highlighted. You can see the green pixels here. And the explainability module would give you this output alongside its prediction. And it would tell you that this is basically the reason why I'm saying this is mild, or these pixels are the reason why I am saying that it is high, or why I'm saying that it is low. So it helps to build trust, especially in the field of medicine, where it is very important to make the right predictions. And it is very important to build trust with doctors and to build trust in this field, right? Similarly, for example, in a recommender system where you're being recommended different movies on Netflix, for example. So explainability can give you, can tell you when a certain movie is recommended to you, why was it recommended to you? Which other movies in your history are basically led to this recommendation for you? So explainability is important and fruitful for both people who are building the models and for people who are just directly using that model in an integrated system or otherwise. So why explainability plays such an important role? Normally, when for most of the models, we use the metrics of accuracy, and we say that okay, if it is 99.3% accurate, the model is doing amazingly good, and if the accuracy is low, the model isn't performing too well, right? So, so we basically use this to how accurate the model is to judge how well it's performing, right? But accuracy is only one piece of that model evaluation, right? It gives you only one perspective of that model. And explainability gives you another perspective. So for example, there was a model that was trained on X-ray images for diagnosis, right? And it gave a really nice accuracy. But when they went deeper to understand why the model is giving the prediction that it's giving, so they realized that the model was basically not really learning from the X-ray image itself. It was learning from the doctor annotations on those X-ray images. So it was biasing towards them, and it was using them to learn the different diagnoses from those X-ray images. So such kind of buggy behaviors can be understood when you're using explainability. So these cases can be catered for, and you basically build greater confidence in your model and your model's performance. So for model builders, it is important because you can identify bias in your model behavior. You can understand how the data set influences model output. So for example, you have a model on a data set that has corona symptoms, right? And you have a data set from different regions in your country. And you want to see how your model is performing on each of those, on data set from each of those regions, right? So you can sample data set from each of those regions and separate out basically your data set into those regions. And you can pass each of those through explainability to understand how the model is performing. Or is it developing a bias towards any of those regions? Or is it completely unlearning from a certain region? Or is it being dominated by a certain region in the results that it's giving out? So it can be used, explainability can be used to understand both your model behavior and to understand your model output for specific data sets, right? And all of these combined, all of these different things combined would basically help you improve model performance, right? On the other hand, for model end users, it explains why how it explains basically the model behavior as a whole. That's one thing, but also to the individual data points in your data set, right? To individual, for example, pictures of retina, to individual X-ray images, to individual data symptoms data set on corona. So to each individual data point, it gives you an explainability of why the model performed the way it performed, or why it gave the prediction that it gave, right? How explainability fits into the ML lifecycle. So the normal ML lifecycle, in very simple terms, is that you gather and pre-process the data, you build the model, you run training and evaluation, you deploy the model, and then you make predictions, right? Explainability doesn't fit into just one plug here. It basically fits into multiple places in the machine learning workflow. So you can, for example, identify data imbalances. You have what if tool, which I'll come to in a little while. You can use it to identify data imbalances. You can ensure that your model is treating all groups fairly. This can be traced back to the text example that I gave, where you're not creating bias towards either Liverpool or FC Barcelona, and your model is treating everything, the different groups fairly. You can set prediction thresholds. So for prediction thresholds, for example, when I have a model that's a cat's dog classifier, right? So I wanted to output a cat when it is 80% confident that yes, it is a cat. But for example, in cases of medical diagnosis, I wouldn't want the model to make a diagnosis if it's only 80% sure. I'd want it to be, for example, 95% sure, and then make that prediction, right? So this 80%, 95% is what are your prediction thresholds, and you can set these up as well using explainability. You can understand your model behavior on real data. So when we're training the models, we're improving the model performances. We're usually doing that on the training and the test data that we have. But as soon as we start to plug that in real life, we see that it starts to perform really differently. And explainability plays a good role here, because you can side by side understand how your model is looking, how differently your model is looking at the data set, right? The real data set and the data set that you trained and tested on. So it gives you a broader and a better view of why the model is performing differently on the two data sets. And then for the end users, you can have surface prediction analysis, and you don't have to worry about everything else that has been going on to that point. And you can just look at what the model is, why the model is giving the prediction that it's giving, like in the example of diabetic retinopathy. So this is just the same flow in an iterative process, because as you get more data, you basically would be repeating in these steps to improve your model, to get better, to make better use of the explainability. So how can you do this on GCP? So GCP has a lot of tools, a lot of features. So you have ML APIs, you have AutoML, you have BigQuery, you have AI platform. Currently, explainable AI can be used with AutoML for the tabular data. And so AutoML is where you train and you serve custom models. You don't need model code. So this is where you have Google Vision APIs, you have text APIs, and all you have to do is you have to get your data set up and you just train the model. And AI platform is where you can build your models and deploy them. It has managed those models, serve those custom models. So for AI platform, currently Explainable AI is available for models that are trained in TensorFlow, both TensorFlow 1 and 2, but it's not available for other frameworks yet. So let's see how this looks with AutoML tables. So it gives you two kinds of overviews of the model, right? Two kinds of explainabilities. The first one is a global explainability of the feature importance in your data set. So for example, it'll tell you which features, the comparison of the features with each other, that which features are contributing more towards prediction, which features are more important in deciding the target class, right? For example, in case of the bike duration, bike ride duration. So which features are contributing the most in deciding how long or how short the bike ride should be, right? So that's a global feature importance explanation that it gives you. At the same time, it gives you an instant level attribution value. And that's something that looks like here. So for a single instance, even you can see which features are more important. Okay, this feature is more important, or this feature is important in reducing the value, and this feature is important in increasing that duration value, and the rest of the features. At the same time, you can also change the values and see what the prediction would be in that case. So for each instance, you can play around and, for example, change the value for this feature and see what the prediction would be in that case. So you can understand your model performance better, and you can understand better to an instance level data points of how your model is making predictions. So at the same time, you can also use this for images, text, and tabular data for the TensorFlow deployed models on Google Cloud. And you have the prediction API, and you can also use the what if tool, directly integrate that. So when you give an image, you basically get an output with highlighted pixels, which basically tell you that these are the pixels that signaled most to the prediction that the model is giving. So for example, in this case, the prediction is right. But even if, for example, the prediction was wrong, you'd still get to see which pixels contributed to that wrong prediction, right? And you'll be able to make adjustments in the model accordingly, right? And the what if tool has a lot of other features as well. I'll come to that in just a bit. But first, how explanations are performed on AI platform. So you build an image, text, or a tabular model in TensorFlow. You deploy that model on AI platform via G-Cloud or API. And you can either use a notebook. So you can even do this in Google Colab, and you can integrate, you can deploy your model on G-Cloud, and you can see the results in Google Colab, right? And you can also integrate, you can also import the what if tool directly in Google Colab and use that right there and then. What the what if tool exactly does and what are the different features, I'll come back in probably the next slide. And you can also use the AI platform prediction API. So that returns you the JSONs and from the explainability module, and you can use them to understand how your model is performing, right? The JSONs and the images as well. So this is how deploying explainable models on AI platform looks like. So you have basically different methods for explainability that can be used. So sample Shapley method or integrated gradient methods, and each of these have some of these, for example, perform better on images in comparison to the rest. So for example, integrated gradient performs, it should be used for images, and for tabular, you could use either of them, but sample Shapley would perform better. So deploying explainable AI models looks similar to this. You define which explainable method basically you're using, whether you're using integrated gradients, or you're using sample Shapley, or you're using the other methods that are being introduced with time into the explainability module. And you can get the results for your model. Let's go to a small demo of how it looks like. So if we're building a tabular model for predicting bike trip duration. So given data on a bike trip, so you have features like start time, day of the week, distance, hour of the day, maximum temperature, how much the wind is, how sunny it is, etc. And we want to predict how the bike ride duration, right? So the data sort of looks like this. You have features, all of these features, and then this is the duration is basically what you want to predict, right? So you would prepare the model for explanations, and you'll deploy your model on G-Cloud. You also pass in basically a JSON for the explainability module, where you basically give in your data. You give in a baseline score, what the baseline score means. I'll come to that. And you basically give what you're trying to predict. Making sense now of the attribution values, the outputs that you basically get. So for each of these the features, you get an attribution value. So the attribution value could be either negative or positive. The larger the attribution value, the more important the feature is, right? For that prediction. And the negative attribution values basically mean that this feature pushed down the duration of the bike, right? And the positive attribution value would mean that this pushed up the duration of the bike, right? So for tabular data, you always have a baseline, right? And each of those features are basically either pushing the value, pushing up the baseline or pushing it down, right? So for example, the distance is pushing it down, the maximum, the start hour is pushing it down. So for each of your instant data points, you get an output attribution values for each of the features with respect to a baseline, right? Whether your output, your predicted duration will be higher or lower than that baseline prediction, right? And if it's lower, then how the different features basically contributed to pushing it down from that prediction value, right? So quick note on baselines. So your attributions are always relative to something, right? And that is your model's baseline. So normally what are the questions that you'd be asking? You'd say, okay, why did X happen? Or why did the model say that this is a cat? Or why did I get rejected from a loan? If the model was basically giving outputs for whether or not you'll get a loan, right? Or why was a transaction flagged as fraud? But when we talk about baselines, we basically, the questions change to why did X happen instead of Y? And that's how explainability works in these cases. So it gives you an explanation. It tries to give you an explanation of why did X happen instead of Y, where Y is your baseline. So why did this, instead of why did this transaction get flagged as fraud, you would rather say, why did this transaction get flagged as fraud instead of non-fraud, right? So the non-fraud would basically be your baseline in this case. So what if to, this is what if to looks like. And it has a lot of multiple things that you can look into. So you can compare two models. You can see data imbalances in your data set. For explanations, it's available on multiple platforms. So it's available with the TensorFlow dashboard. So alongside all the other things that the TensorFlow dashboard gives, which is being able to see your model layers, being able to see the loss graphs, the accuracy graphs, etc. You also have a tab for what if tool, and you can use that to analyze your model, right? It can also be integrated with Google Colabs. You can import what if tools in your Google Colabs. You can use it in Jupyter notebooks. You can use it in cloud AI platform notebooks. So the what if analysis can be used to even compare two models to an instance data point of how the two models are performing on a single data input and why they are making different predictions. You can use it to judge bias to judge imbalance in your data set, and for threshold simulations of how the model will be performing if you change thresholds, right? So for AI explanations, if you also have AI explanations integrated with your model, you get this extra feature where, as we saw earlier, you get attribution values for each of the features of the data points, right? So by clicking on a single data point here, you will be able to see attribution values for that data point. And you'll be able to make changes, play around with it, and see how the attribution values would change and how the model prediction would change. And you'll also be able to compare model performance and model outputs for a single data point, and how two different models are performing on the same data point, how the two different models are getting different attribution values for the same data point and why. So for example, if you're building an image model for flower classification and it gives you the type of the flower, then this is how you would make sense of the highlighted pixels. So explanations basically return the top 60% of the pixels that signaled most to the model prediction to say, okay, this is a tulip or this is a dandelion flower. For this model, for example, we want to be able to understand, we want to be able to use these outputs to understand that the model is performing right and it's looking at the right features in the pictures, and it's associating the right features to the right flowers, right? So for example, in this case, it's associating the tulip flower to the oval shape that it has, right? And in this case, it's associating it to these white dandelions that it has, right? So we want to be able to, also we can use explainability to better and quickly, much more quickly understand if our model is looking at the right features and if it's performing the way that we want it to perform. So for example, if the highlighted pixels were elsewhere, or if the highlighted pixels were on these green areas in the background, then we know that the model is not performing well for this specific class, but it's performing well for this class, right? So we can make adjustment for this class, maybe do more data augmentation, maybe get better quality images for tulips. Maybe there was class imbalance, and that led to the model not being able to learn the features right in tulip flower pictures. So all of these judgments and all of these analysis can be done using the results from Explainable AI, right? To summarize, basically, Explainable AI can help you explain why an individual data point received a prediction, right? And what basically your model saw in that a data point to give the prediction that it gave, whether it's tabular data, text data, image data. You can debug odd behaviors from a model, right? You can refine a model and data collection process. You can verify that the model's behavior is acceptable. So you can verify that, yes, it is looking at the right features and giving the right outputs. Or you can basically debug that it's giving outputs which are right to some extent, but it's not really looking at the right features. It's learning the wrong things, and that would in future cause a problem, and you maybe have to start from scratch again. And maybe at that point you'll be like, okay, but performing all right, what basically changed? Even though it would have been the model all along, right? But you wouldn't have figured that out maybe because you were getting higher accuracy because of a feature of the model learning something that it wasn't really supposed to learn. That wasn't the idea of the model learning, right? You can present a summary of that model to your clients, to people who are not equally technically aware of how the model is performing, to your stakeholders, to building trust video client to building trust with doctors in medicine to building trust even for yourself in the models that you're building, right? So that's about it from my side. And if there are any questions, I'd be happy to take them.
Hi, Aqsa. Right, great presentation. Hi,
Thank
Aqsa.
you.
So we do have a few questions here from our YouTube comments. The first one is from Weizhen Wei. It's about do we need to show outlier data to the model to increase the accuracy of the result?
So not generally, you would want to pre-process your data to maybe remove the outliers in your data for your model to perform better, right? So that's the general way of dealing with outliers in the data.
Okay, got it. I think that should answer your question, Weizhen. So another one is actually about the flowers. Actually, it's like a two-session question for so far. So it's about, so then in case of the flowers, it will choose the flower with a full shape and not the partial shaped ones to make better predictions. Is it how should it work?
I think I'm still confused about what what the question is being asked. But I'll re-explain how explainability works for flowers. So when a model is predicting the class of a flower, right? It's when it's learning and it's looking at the pictures in the training phase, it's trying to learn on some features for each of those flowers. Okay, so to say, okay, you know, if so this is a tulip and this is a sunflower. So the model is looking at something in those images, right? Some features and associating them separately to this is a sunflower and this is a tulip. But because we just see the predictions, we just see the outputs, we are unable to completely understand why the model called this a flower, right? Or why the model called this a tulip. And obviously there are methods to go deeper into the layers and see what each layer has learned. But obviously that's a longer method, and that's not a plug and play method like explainability. But when we use explainability, what explainability would do is, for an image that you give to the model, it would predict whether or not it's a sunflower or whether it's a tulip. And for that particular prediction, the model would tell you which pixels in the image basically contributed to that prediction, or which pixels in that image made the model say, okay, yes, this is a sunflower, right? So for example, when I look at an image of a sunflower, I look at, you know, the yellow petals, and I'll be like, okay, this is why my mind says that this is a sunflower, right? Similarly, for the model, it will associate some features to that class. And in that case, when you get the explainability output, you would get an image with highlighted pixels, and the model would be able to to give you an explanation of what pixels in the image, what areas in the image basically made the model say that yes, this is the sunflower. I hope that answers your questions.
I think so far also did clarify that it's about a bunch of flowers for a question. Will it choose the one with a full shape or a one that is partial shaped?
So for each, it depends on, so if your data had a lot of images which had with bunch of flowers and not just a single flower, right? So the model would learn accordingly, right? So for pictures where you have bunch of flowers or bunch of tulips in the images, the model should ideally be able to understand that these are multiple tulips, right? And it should highlight pixels of features for each of those tulips, right? Like we saw in that image, that it was highlighting the shape for each of those flowers and not just one of them.
All right. I think hopefully that answers your questions, so far. And hopping on to another one, which is about another one, a different one, is do you use graph search or SQL search in explainable AI?
Okay, so explainable AI, technically what happens at the, so for us, when we're using explainable AI, it's basically just as simple as plug and play, right? So you basically just define which method of explainability you want to use. You define this is your output layer and this is your input layer, and you define these simple things and you just start to get outputs for explainability. But obviously the algorithms that are being used for explainable AI at the backend are they're interesting methods. There are multiple methods. I'd explain one of them, and that's based on game theory, basically. So, for example, in game theory, you have multiple players playing together for a given goal, right? And some players would be performing better than the other ones. And you, in game theory, you basically judging for each of those players, which player is contributing the most, because that player should get the most reward then, and which player is contributing less. The explainability sort of, it's a very interesting concept that they have sort of fit into explainable AI, inspired by how game theory works. And I would definitely suggest for you to go read up on it, on game theory and how that has contributed to ML explainability. So they've used that concept of game theory to and applied that to features, where you could think of each feature as a different player, and you could think of the model output as the reward. So how each player is contributing to the model output, that concept has been used in explainable AI.
Cool. I think there's one more question also from so far, is it possible to put 100% threshold for the model?
It is possible to put 100% threshold for the model, but you'll probably not get results for that, because this usually only happens in cases, so you do not really get 100% for a class, right? You do not really get 100% confidence for a class unless your model hasn't learned much and it's completely biased towards a class, like 100% biased towards a class. You wouldn't really be getting 100% confidence for a class output. So you can put in 100% threshold. Obviously, that you can do as you like, but in that case, you shouldn't do it, because you wouldn't get results for it. So even in cases where the model is very, very confident, it'll be confident to like a 98%, 99%, 99.7%, but it's never usually 100%, right? Unless your model hasn't learned the way it should have learned, and it's completely biased towards class, and it's just always outputting 1 instead of 0, for example, or always outputting cat instead of a dog, for example.
All right, I think we'll move on to the final question here, which is, does your explainable AI engage in recursive questions and answers like human do?
No, not currently.
Okay.
It's a new thing that has been introduced in Google Cloud, and it's there's still a lot of new features coming in, and it's definitely something to keep an eye out for. It will get you will see support for other frameworks as well. You will see more methods being introduced in explainable AI as well, and I think they're just expanding. It's an active research area for them, and active development and a product area for them.
All right, cool. So that's the final questions here. So if you guys have any more questions for Aqsa, I think Aqsa has the contact, like Twitter account or LinkedIn account on
Yes.
the slide. Yeah. Well, what's the Twitter handle for your Twitter
Second.
account? So that, yeah, I think that I saw one as well. Yeah. So if you guys have any more questions for Aqsa relating on explainable AI or anything about ML, feel free to get in touch with her via Twitter or LinkedIn. There's the Twitter handle there, and also a LinkedIn link there as well. So if guys have questions, feel free to just ping her. So I think that's all for today for Cloud Devfest, everyone. Due to some scheduling issue, we won't be seeing Armel for this time, but we do hope that to see you all in the next monthly meetup for GDG Cloud KL. So once again, we would like to thank Aqsa for the amazing talk, and also Asyrul as from our first speaker. So it was amazing. It was an amazing morning for GDG Cloud KL, and as always, I think before we actually go, I also want to introduce some of the things as well. Let me share screen from tab. All right. So yeah, again, if you just join, there's GCB Boleh currently conducting GCP Boleh 2.0. Is actually a GCP learning session, but it's a month long, and to sign and by completing the quick lab session, you actually you can level up your skills on the GCP's technology, and also you can score swag. That's one of the most important things in GCP Boleh anyways. So it's from 16th of November until the 15th November 2020. And to sign up or to get more information about GCP Boleh, you can head on to this link, goo.gle/GCP Boleh. So feel free to check it out. Of course, as always, although it is an online event, we really appreciate that you can actually provide us feedback to actually let us know that how you feel like for an virtual event like this, what can we improve and how we can improve. And if you are interested in speaking in our next GDG Cloud online meetup session, you can also leave your contact there in the feedback form. So the feedback form link is as below, bit.ly/GDGCKL Devfest 2020. It's a little bit long, but my suggestion is just take a screenshot. All right. Take a screenshot, 3 seconds, 3, 2, 1. And of course, after this as well at 2 p.m. Malaysian time, we have another session from GDG Kuala Lumpur, the OGs of GDG in Malaysia. So we have we have 3 speakers here: Xiang Yi, Samjin Tana, and Jawad. So they'll be talking about topics related to Firebase. So head on to GDG KL Facebook there to check out for their information, and yeah, stay tuned. It's on 2 p.m. today. All right, and as always, thank you all for today, and see you all next year for 2021's Cloud Devfest. And remember, stay safe, wash your hands, and yeah, that's it. Bye, everyone.